Good morning and welcome back to our seminar talk, SimTalk series. We this year have a new group of presentations, which we are called the Regenstrief Institute Grand Rounds. That's where we're going to have outstanding presentations from speakers across the region, including our faculty, staff. And I'm very happy to be able to start this again after several months with no talks and seminars from in our institute. So happy to start this. Without further ado, I'm gonna pass the word to Dr. Peter Amby, our CEO and president, and he will kick off us in our new series for the 2021 year. Thank you.
Thank you, Anita. Thank you for your leadership and for relaunching our series here and taking us back into the realm. So this is exciting to have this Grand Rounds kicking off again. I know we all are eager to do this in person as soon as we can, but it's great to at least be doing it virtually again. And it's also my honor and privilege then to introduce our first speaker in the series, Dr. Umberto Tachinardi, who many of you know, but some may not. So I'm going to briefly embarrass him with a little bit of an introduction. I think most of you know that Umberto joined us a couple of years ago. I think in April, it will be 2 actually. So it's relatively recent, but he's certainly jumped in with both feet and has many different roles and responsibilities in the organization, has had a major impact already. So he serves, of course, as our Chief Information Officer at Regenstrief and for the Precision Health Initiative for IU, and directs research informatics initiatives for the Indiana CTSI. He is, of course, a scientist and assistant dean of clinical informatics for the School of Medicine and a professor of biostatistics at the School of Medicine. He has decades of experience in the realm of biomedical informatics, having started his career as an informatician, a physician, and CIO in his home country of Brazil, and then moving here to the States a couple of decades ago to lead multiple different entities, including at the University of Chicago, and then most recently at the University of Wisconsin, where he was the CRIO and was responsible for a lot of the activities that happened across the schools of medicine, public health, and the University of Wisconsin medical system, health system there. He's a fellow of the American College of Medical Informatics, longtime member of AMIA, and last year was inducted as a fellow of the International Academy of Health Sciences Informatics as well. So he's going to talk to us today about some of the things he's been leading, including the role that he is leading for us as the leader of the EntryC Honest Data Broker initiative. So Umberto, take it away. Oh, and you're muted.
You're on mute, sir.
You know, that's the only way to keep me shut up. So good morning, everyone. It's a pleasure to be here. Actually, it was sunnier, but not so much right now. And it's been a very, very interesting and nice time since I got here. As Peter said, it's almost 2 years, half of it at home, working from home. So I probably have half and half of experience inside the building and working from home, which is interesting for everyone. This Honest Data Broker that I'm going to present today, just some highlights because it's something that would take a lot longer to go into more details. Let me just put this in the screen, and I hope you're seeing a slide, a full slide, bringing it all together. So that's the idea, is to bring it all together. This was a contract competition. It was a bid that we won. And the idea is to combine 2 things. One is a technology that produces hashes. I'm going to talk about that, out of identifiers. And the other one is to use those hashes to provide matching for patients, same patients, to provide deduplication, linkage, etc. I'm going to talk a little bit about that. So because NIH is the contracting side of things, we are trying to address primarily their needs. And what they want is to combine their multiple databases or multiple domains of data as much as possible. But the problem is that majority of their data is de-identified. And because of that, it's impossible without doing something to reconnect the data pieces. And we all know how important it is to have the broadest spectrum of data available for analysis to produce new knowledge, insights, etc. So in this particular case, we are aiming to start with EntryC that you see here, which is a COVID cohort, and then move into other areas like All of Us, which will be our next. And All of Us is a program you probably heard about, and you can Google it. And because I don't have time to go over each one of them in details. And then the imaging, the cancer imaging, and the biodata catalyst. What the summary is, EntryC is EHR data. All of Us is a combination of EHR data, genomics, and surveys. Cancer TCIA, or Cancer Imaging Archive, it's as the name says, radiology images. And Biodata Catalyst is a plethora of clinical trials. So that's the scope. And how can we bring the data together without compromising patient privacy, given that it's de-identified? And the idea is to block those identifiers to be used in the identification process, but the solution is to replace them with something that will be used as an avatar to those identifiers. And there are numerous regulatory and privacy considerations to data sharing, like HIPAA, FERPA, etc. And PPRL, which is the name of what we are introducing to you this morning, which stands for Privacy Preserving Record Linkage, satisfy all those requirements for the regulations on the left. And so let's give you an example of how this works. You have a person, John Smith, that has Duke as their primary home, primary care home. And then this John Smith is also being seen at University of North Carolina for his COVID complications. So he's at an ICU at UNC. And now John Smith has his identifiers processed through the software that will produce the tokens or the hashes, and the same happens to North Carolina identifiers. And you see that there is this array, there's a string of weird characters that is what we call the tokens or the hashes. And what we do when we go to compare those tokens, and actually I don't remember why we had the wrong tokens on top of here. So forget about the strings that you see on the middle of the slide. Look at the ones to the right, because they are the same. So the same identifiers will always produce the same tokens. That's the spirit. But you cannot get back to the identifiers from those hashes. So in this case, in the EntryC case, we are using 18 tokens, certified tokens. And what form those tokens are listed here. So you have a combination of last name plus first initial, first name plus gender plus date of birth. Another token will be, so when we talk about token, it's important that you think that we are simplifying, because we usually use a token set. So we don't use one token only. And the reason is probably obvious at this point. We may have missing identifiers, so we will not be able to produce all those tokens for all patients. So it's important that we have a combination of identifiers used to produce different tokens, so we can match more patients, even if they don't have a few of those identifiers. Obviously, the power of matching gets higher the more identifiers we have per person. So what we want to balance here is uniqueness. We want to be resilient to data entry patterns and, for instance, typos. And in order to soften the effect of typos, for instance, is to use SoundX, which is instead of using the characters that form the name, we use the SoundX code for that. So it's the sound versus the graphology of the name. So when we do the matching, we have a number of tokens. We are showing only 3 here, and what happens is that we will try to see how many of those tokens are the same, and that will give us confidence that we are identifying the same person. And you can see in this example that in one of the databases, John Smith had a typo. So there is a missing age in the name on the bottom, John Smith. And you see that because of that, token number 3 that actually uses the string of characters for John, for the first name, is different. So if we were using only that token, we would not identify that those 2 John Smiths are the same person. But because we have more tokens to compare, we found other tokens that are matched, and that's how we truly match patients. We have an equation that will define for each token set and each use case how many of those tokens need to truly be matched to identify a match, and maybe some tokens will be stronger, so they will weight more in the equation than others. For instance, if I have a token that uses social security number, this is a very strong token, right? So it's more powerful in matching than a token that uses a string of first name and the date of birth that are more prone to typos and stuff like that. So that's the challenge we are addressing. This is what the software does, and I forgot to mention, I should have, but we have a partner that produced the software that crunches the identifiers to speed out the hashes or the tokens, and that partner is Datavent. So Datavent is a company based on, and their main product is the software that produced those tokens. So, but we are the honest data broker. So we receive the tokens that are sent by the sites that are producing the data. And we don't receive data here. We don't receive identifiers. We receive only those strings that you saw there, the tokens. And we use them to produce maps that, or to compare with other hashes and see if we identify duplicates or when people ask us to do linkage, we try to find other occurrences of the same patient in the many databases, and then send the information about what identifiers should be used to link that data to where the data is. And the data is not with us. The data is with what we call the enclaves, where the data, or repositories where the true data is. And I'm gonna go back to this in a minute. So I know it's sounding confusing. I'll get back to that in a minute. So the hospital will create the hashed IDs with the Datavent software from left to right, sends those IDs to us, and they also send the pseudo IDs, which are IDs that are sent also to where the data is going. So the data that goes to the, in the case of EntryC, that goes to the Palantir, which is a company that operates the NCAT's EntryC enclave. Palantir receives data and the pseudo IDs. We receive the pseudo IDs and the tokens. And the tokens are the pieces that allow for matching. The pseudo IDs are unique. They will never connect back to any identifiers. So they need us to tell, oh, this patient also has pseudo ID B or C. And then we can produce important functions like deduplication, linkage, etc. So they also, and that's the third bullet here, they send the data to the enclave. So what the hospital do, they create the hashes, they send the hashes and the pseudo IDs to us, and they send the data and pseudo IDs to the enclave. When we receive the data here, we match that against what we already have. And if we find a match, we will put that information in a match table and leave it there so we can take action in the future for that. Some actions may be more immediate, like if we find a duplicate for the same enclave, we may want to inform that immediately. So there are operations that will be performed very quickly, and others that will be performed only when someone requests a linkage. And the analytical platform, once we receive a request to produce linkage, for instance, now we know that there are 2 or 3 patients in 2 or 3 databases that we want to combine the data. We send a map of the pseudo IDs and say, this is the same patient. And then they can connect the images with the EHR data, with genomics, etc. So this is kind of an animation of what we do. So the hospital send us, this is a repeat-ish of what I just said. They send us the pseudo IDs and the hashes, as I mentioned, and they send the pseudo IDs and the data payload to the enclave. And what we do is that we receive those pseudo IDs. I mentioned that before. We do the matches. And then when we detect duplicates, we inform the platform that there are dupes. And when we receive requests to do linkage of data, we use our match table to connect the right patients to in a map that will be sent to the enclaves to produce the true data integration. So I'm going to go quickly here. So this is the architecture of what happens. The enclave receives data payload, we receive hashes. But because we have various use cases, I mentioned before, we have the EntryC. Imagine that the left side is EntryC. The right side here will be, for instance, all of us, TCIA for imaging, or Biodata Catalyst. All of them will produce the hashes sent to us, and we will be the big broker for those tokens. And one possibility is that the physical integration of the data will occur in a neutral platform. So the data is currently stored in an enclave for NCAT or in other repositories. For all of us, for instance, use Google in a Vanderbilt contract. So all of us data is in the Google Cloud, and EntryC data is in a Palantir resource. But maybe one possibility is that HPC will be in a different cloud or a different infrastructure. And what we will do is that we will send the link maps and tell EntryC, for instance, send to the HPC the data you have for those pseudo IDs. And we will send the same message to TCIA and send all the images you have for those pseudo IDs. And they will come to the HPC platform, and HPC will do the physical linkage. That's one possibility. The other one is that there is no HPC in the middle, and the Enclave will receive the images, or the imaging repository will receive the EntryC data. So there are multiple possible combinations. That's not our business. We will just send the maps to the right operators, and they will produce the physical linkage. And that's where the cool thing starts to happen. Let me, yeah, this is a repeat. So I will repeat this because I don't want to see any confusion. We are not receiving identifiers. We are developing a platform that enables PPRL, and we don't do the PPRL here. We provide means for. We harmonize tokens for multiple use cases. We never receive data. We never receive true identifiers. This is happening in the site. Governance and compliance are enforced here. So we follow governance. We don't develop governance. We enforce and we apply governance and compliance. Matching of individuals use multiple hashes. Remember what I said before, we don't use one token only. We use a token set. So we need more than one. In the case of EntryC, we are using 18 tokens. Deduplication is another benefit of the matching process. So now that we are back to the use case I just mentioned. So now we did all the magic on the Honest Data Broker with the tokens. And now we can combine data from John Smith. And this data will be, for instance, a combination of images and EHR data. And they can finally get connected because of this machinery that we are putting in place. We will start to receive some possibility to link genomic data for the patients from all of us. All of us collect tissue for sequencing, and very soon they will have genotype data available to be linked. TCIA is already good to go with the images. And some genomics will also come from biodata catalyst. So many different sources will have different kind of data, and some patients will be common. And that's the goal, is to find the patients that are common to those multiple resources that can be combined. So this is what PPRL can do. We can do multimodal data analytics. We are supporting that. Patient deduplication, cohort discovery, and prospective observational linkage. So we can add prospective data, which is a very cool feature. You know that de-identified cohorts usually are snapshots. They don't get increments, temporal increments in the future, because you cannot reconnect the data. You need to refresh the whole thing all the time. And here we can do that. And benefits of hashing: prevents double counting patients across providers, allows for longitudinal patient follow-up, genomics linkage, improves insight into mechanisms and clinical efficacy, improves scope and quality of answerable research questions, can fill gaps in diagnosis codes. For instance, ground glass opacity is a marker of COVID, even if COVID diagnosis code absent. Supports improved pharmacovigilance by linking clinical trial patients to outcomes. And I will stop here. I know there are probably a ton of questions waiting for me. And this is where things can get more clear to you by being able to ask your questions. And Peter is going to mediate the questions.
Yes, happy to. Yeah, thank you, Umberto. I know, some of us have been closer to this than others, so that was a great overview. It made sense to me. I imagine for some people who are hearing it the first time, they're going to have some questions. So this is a great opportunity for people to ask. You can either put your questions in the chat or you can unmute yourself if you prefer. And maybe while people are doing that, Umberto, let me start with one of the questions that I know we've been thinking a little bit about, and you've been giving a lot of thought to, beyond the use of this capability for the current N3C activities. Can you say a little bit about what you think are the potential opportunities now that we're developing this capacity and this capability for other applications and other things we could pursue here at the Institute?
Yeah, obviously. Yeah, I think this can be a game changer in so many areas. And for once, we can start replacing all those study IDs, etc., for most cases with a token set, and with that guarantee to our researchers, the people that are using the data that Regenstrief produce, potential linkage in the future. That would be, in my opinion, super awesome. Right now, we are not able to provide that. We can also produce the Honest Data Broker for industry in clinical trials and things like that. They definitely need tools that allow us to use EHR as the source of information. On the other hand, they may not be able to use that for non-consented patients that would require identification, etc. So being able to replace identifiers and being able to grant exemption level to data may open a completely new area for us. It doesn't replace synthetic data, for instance, which is another option for anonymization. But I even think that this could be used in combination for that. So, in summary, what I'm trying to say is that I see that as becoming an internal product that we can use for our clinical trials. We can use for our cohorts. But also could be a service that we can offer to the school and any other area that requires the identification.
Great, thank you. I see there's some questions and some chat going on. Of course, Sean Granis is part of the research team as well. And I see, Sean, you've already jumped in to answer some questions, but it might be worth just speaking through that. Sean, do you want to maybe go off mute and speak a little bit to the conversation you were having with Lava?
Sure. Yeah, so I've been funded by PCORI for the last 4 years to do research in privacy preserving record linkage. As a result of that research, we've created 4 manually reviewed gold standard data sets. We use those data sets to evaluate the performance of the match accuracy and, and really saw very good performance among the health systems data. I don't know how much detail you want me to go in at this point, Peter. I've got some slides that we presented last week at N3C, but we show sensitivity and specificity above 98%, F-score above 98%. We're looking at performance by race and ethnicity and gender right now, just to make sure that we get reasonable performance. As is generally known, matching among younger people, particularly newborns, is challenging, and we have some work to do in that space.
Great. And I see there was another question there around describing pseudo IDs. And do you want to say a little bit about that? Because it looks like you were responding as well.
Yeah, a pseudo ID is just a meaningless ID. It can be the hash could be a pseudo ID, but the key is the pseudo ID on its own is meaningless. It is the map of that pseudo ID back to a real ID that is maintained by somebody. That's where it's important. So you can pass around the pseudo ID and not know who the person is. But if you ever want to go back to it, somebody somewhere has to know this pseudo ID maps back to this real person. But of course, that mapping is kept very safe and secure.
Yeah, I will make a comment here to add to Sean's. You can see in the slide that I put here. So in the case of EntryC, for instance, and remember, every case will be slightly different. So EntryC receives the payload, the data payload with an identifier that they call the pseudo ID, because it's not connected at all with any true identifier of the patient. And that's their way to de-identify the data. So they replace the identifiers with pseudo IDs, and then they ship them stripped out of the heap identifiers, but they replace those with the pseudo ID. When the platform ingests the data, they connect each element of data with the pseudo ID that was sent, and then they create another one, which is called the EntryC ID, which it's kind of a complication, and I don't need that to explain to you. So pseudo ID is just, and you did that, I think most of you here assign pseudo IDs in research you did in the past. Because it's very, even for trials where you have consenting and you have true identifiers, it's best practice never to use true identifiers stored in many places, etc. We tend to call that a session number or study IDs or whatever. All those things are pseudo IDs. And as Sean said, even the tokens are pseudo IDs, but we prefer to separate those two, because the platform because we are the honest data broker, and the tokens are ways to match patients. The platform that contains the pseudo ID is not allowed to compare data to try to re-identify anyone. And we are not trying to re-identify also, but we can match patients, which is different than re-identification in this case. And so the pseudo IDs are numbers that they have. And when people go to the cohort, they will try to find a list of patients with certain criteria, and they will receive back this list that you see on the right. But this list does not allow for linkage. And that's where we add the honest broker component, because we receive the pseudo IDs. We have the pairs pseudo ID tokens, and then if we have matches, we can get back to the Enclave and say, look, you need to connect pseudo ID 123 with pseudo ID, I don't know, 1,000,000, and that's what you do. So that's the answer, I hope, for the pseudo ID question.
I see Brandon also asked a question and Sean responded, but I think it might be worth just delving into again for another moment or two. As data about the individuals is updated, the specific question there was about name changes or gender changes or what have you, but can you say a little bit about what happens as sort of data get updated, let's say in the future? How does that get handled?
Sure. So part of the reason that we use 18 different token combinations is we try to take a view into the patient demographic record multiple ways, so that in the case, not all of our, in fact, most of our token combinations do not use gender. Some do, but by having some tokens that avoid frequently changing values, you can get it. If you miss it with one token combination, you're likely to find it with other token combinations. And if when that change occurs, if you've got other combinations that can link that person back into the overall ID, then it just becomes part of the overall understanding of that group's ID. So again, the short answer is the way you accommodate changing values is with multiple token combinations.
Yeah, I just put on the chat box because I saw a comment, and I know this may be outdated now, but just to be very clear, medical record numbers are true identifiers. They cannot be confused with pseudo IDs. On the other hand, MRNs can be used to calculate hashes, to produce hashes.
Do you want to also respond, Umberto, to the latest comment from Lava?
So this matching could be useful in tracking the patient over the. Yes, Lava, definitely. That's really the longitudinality, the reconstruction of longitudinality using this mechanism is probably one of the most important use cases of this technology. Absolutely. And actually the longitudinality can be restored both using data from the same provider, but also in multiple providers. So that's the beauty of thing. You can use that intra-provider, but you can use that also as an inter-provider linkage tool. Thank you for that. That's a really good comment.
Folks, Suranga here. I did have a quick question. I found the presentation very fascinating, and I saw quite a bit of parallels across the privacy preserving work and a different grant I'm working on with Sean. Particularly, the concept of finding most effective blocking schemes and using them as an identifier. I guess, are there effective parallels to work together? How can these projects work together? Is that something that has been thought about?
Suranga, can you please repeat the question?
Sure. So I found the whole presentation quite fascinating and definitely very interesting. I saw several parallels between this work and the other privacy preserving work we are working on with Sean and Pokori, where we also look at mechanisms to identify effective blocking schemes.
Yeah.
Has there been any thought about parallels and how these two might relate?
Yeah,
I think Sean may be, yeah. I mean, Sean is a natural bridge, right? I mean,
yeah,
these projects.
Yeah. So not yet, but I think the main difference is that the current way PCORnet is operating, they are not using the Honest Data Broker component as we are for EntryC. They have the PPRL engine, but they don't have a neutral party operating the PPRL mapping. Sean, would you agree with that?
Yeah, that's how the PCORnet Common Linkage Group is doing this. My research is completely independent of that, though. It's not bound by that. So the work primarily that we've been doing is asking the question, there really haven't been good performance metrics for privacy preserving record linkage in real world data. Abel Coe's done a little bit of work, but there hasn't been broad evaluation of that. And so what we're trying to do, similar to the work I did in clear text, probabilistic matching, probabilistic PPRL really doesn't exist right now. And the hypothesis of my grant was, gee whiz, why aren't we taking the great stuff from the probabilistic world and applying it to PPRL? And so that's the work that we're doing there to optimize the accuracy of PPRL, leveraging everything that we've learned from patient matching previously.
I think it's worth maybe speaking to that point too, to say that as Umberto described at the beginning, this is the work that he was presenting, of course, is contract-based work to sort of do something for this particular initiative that is rather operational, but it of course illuminates a lot of unanswered questions and opportunities for additional research. And in fact, one of the things that has already been identified by a number of stakeholders, including at the NIH, is, wow, as you all are doing this work, isn't there an opportunity to do research here? And of course, the answer is yes. And so, you know, with Sean's role in this and the work that he's otherwise leading for Picori, et cetera, I know that's one of the things he's thinking actively about. Abel Coe, our colleague on this, is also working with us on this. And so I think the other reason to have done this as a grand rounds is to also really illuminate the potential possibilities for people like you, Suranga, and others to say, are there other research questions that potentially we could leverage this opportunity to ask and answer, and potentially not only provide this service back to the NIH, but be able to also use this as an opportunity for additional grants and additional research.
Yeah,
Definitely.
So I want to comment on Alan's question here, pharmacy records. So of course, anything that contains identifiers that can be replaced with tokens are potential for linkage. So what we cannot do is link data that is stripped out of the identifiers, and the identifiers are not producing the tokens. So we cannot get back to de-identify data unless we have a break the glass option. For instance, most places, when they produce the pseudo IDs to de-identify subjects, what they do is that they keep the identifiers and those pseudo IDs stored in a separate place. And this is what most of you write in your IRBs you will do, and keep the key separate from the data, et cetera, right? So, but usually there is a break the glass option, which it means, you know, in the case of, you can reconnect those two things. So for retrospective data that was not produced using the tokens at the point of the identification, the only way to reconnect that data is using the break the glass, if there is that possibility. We are trying to convince MIDRC. Right now, there is this group at the University of Chicago that we call MIDRC. MIDRC has the imaging for NCI, and what they already operate an equivalent of PCORnet. So they operate their own linkage PPRL group, but they use GUID for matching. And GUID doesn't use matching because it's, you know, you have a GUID and you use the GUID and they have the maps. The problem of the GUIDs is that it makes re-identification more possible. So the more people use the platform, the easier it will be to identify patterns and try to re-identify patients. So this is the beauty of the Honest Data Broker. We are a neutral party, and we are the only ones that can produce those maps, making it one step more in challenging against re-identification. In the case of the pharmacy data, etc., we are working. I know that NIH is working, for instance, with CMS to try to hash all the claims data in their database. So that's a huge thing that they want, is to have CMS doing a primary hashing, because CMS has all the identifiers in their database, which makes it all the time complicated for people to get used to use those data. And pharmacy is the other one. I think if this works well, and we hope it will work very well, more industries or more data guardians will start to consider that as a way to protect their data and their patients and privacy, and at the same time make it more accessible to research and other uses. That's a good question. I appreciate it.
So maybe as we draw to a close, it would be worth taking a step back, Umberto, and just saying a few words about the EntryC data resource itself, and also the corresponding data resource that we have here, Cortico, just so that people are aware of, you know, the other opportunities, not per se around data linkage, but around the databases themselves.
Yeah, so EntryC has, I don't know, 90 healthcare systems donating data. Right now, I think they already have data for 50 of those 90 that were contracted. And so it's billions of rows, billions, I think they have hundreds of thousands of patients at this point, probably millions level, because they have controls. So just to be clear, they have COVID positives and and 1, 2, 3 controls in their database. So the way to use that resource, you as a researcher, you go to the EntryC website, which is easy to Google. Just put EntryC COVID. Yeah, Peter put a URL here. And you will go there. We have the agreement. So you're authorized to put a request in the platform. And what it happens is that if they approve, you can either bring your analysis, your queries, etc., in the form of Jupyter books, and I think they accept R codes also. And then you run that against the database. And there are some rules about the output of those processing. Some will be exportable outside of the enclave. Others will not. There are many rules there. There's a lot of training sessions for using EntryC. Actually, yesterday there was a few, and you can find the schedule in the EntryC website also. We have an equivalent version of the EntryC here at the Regenstrief, but it's limited to the state of Indiana and to what INPC has in terms of data, which is very good because we have more granularity of data than what EntryC has. And granularity in this case means we have more data elements per case than EntryC. EntryC limited the amount of data elements that they have. We are having more granularity available. The way to use our data right now is to come through our data core request form, and we will grant access. We will grant an analyst to help you extract the data you need. Very soon, we will have 2 important new things. We will have a self-service tool that will allow for feasibility queries, and we will have a synthetic version of Cortico, which will allow a much easier access to, including a full copy of the data for machine learning, AI, etc. So those are the tiers that we have around that. Peter, is that what you were expecting?
Yeah, I think that's great. And I think if people need help navigating those, as you pointed out, they can go to the data core for help. I think the other difference I would point out is that, again, the EntryC data set is a limited data set without identifiers. Whereas, of course, the Cortico data set for certain use cases, if it's necessary and approved and appropriate to re-identify people for certain kinds of studies, then we could do that because it's internal to our organization.
Yeah, we can use that for recruitment lists and enrollment, etc.
Right.
You're right.
Excellent. Good. I just thought we would take the opportunity. So great discussion, everybody. I was going to ask if there's any more questions. It looks like we got one more here. Do you want to take that, Umberto?
Documentation which highlights key difference. We don't have one highlighting the difference, but we can produce one. I think that's a good idea. We have both. So let's be clear. We have both, but we don't have one document that summarizes the differences.
But this is a question we actually were just talking about this morning, Suranga. It's absolutely important because we recognize that that's an important thing to guide people. And in fact, there's some opportunity to even really pressure test this in a sense, right? What are the, and again, there are multiple sort of research questions that people are thinking about, including some of us around saying, okay, if you want to answer certain kinds of questions, is it better to go to one resource than another? And in order to answer that, we need to do some initial studies across the data set. So that'll be possible here relatively soon.
Thank you. Sounds good.
Great.
No more questions? Okay, so thank you all for being here today. There was like a very important and exciting conversation about data brokers. I just want to let everybody know that next week we have our first SAM talk. The speaker for that SAM talk will be Dr. George Ripsack. George is the Vivian Belmont Allen Professor and Chair of Biomedical Informatics at Columbia University and the Columbia University Irving Medical Center. And he'll be talking to us about physics of medical record and observational research. So very relevant to the topic, sort of like a continuation in some ways of, using data and for clinical research. And we'll hopefully that everybody will be here next week to listen to George. Thank you so much, and you all have a great day.